Hello there, my name is Luis Gonzalez, and today I'm going to be presenting the aquatic conveyor belt, understanding how our catch can impact our health. This is a brief presentation on the aquatic food chain and how the transfer of nutrients and pollutants from the sea to land. So these are the original rules for the original game that was supposed to go with this presentation. Feel free to look and read and just enjoy the little diagram after this. So we'll start with the recap of the food chain, some important definitions. So there's prey, an animal taken by a predator as food. So if you look at this diagram to the right, you'll see that the fish is prey to the kingfisher and the caddis is prey to the fish, but the leaves and algae are not prey to the caddis because they're just leaves. They're not another creature. So predators are organisms that primarily obtain food by the killing and consuming of other organisms. So in this diagram right here, the kingfisher is a predator and preys on the fish. The fish is also a predator and preys on the caddis. But again, the caddis only eats leaves, so the leaves are not its prey. So it's not a predator. And the apex predator, a predator at the top of the food chain that is not preyed upon by any other animal. So the kingfisher in this diagram is the apex predator because it preys on other animals, but nothing preys on it. So it's at the very top of its food chain. And every time one of these animals consumes either their prey or their non-prey, in this case, the leaf matter, there's a transfer in nutrients from one animal or one organism to the other. Right. So following this, we'll talk about the ecological impacts of aquatic migration. So the land-sea nutrient exchange is basically fish carry nutrients from far away. And their land-based predators, such as humans, bears, and birds, spread those nutrients across land. Right. So a lot of fish, like the salmon that this bear just caught, come from far away from the sea and then swim upriver for breeding. And in that process, when bears and humans and other creatures like prey on these fish and then spread their like bones or their leftover parts of the body of the fish, or poop the fish once eaten, they are spreading a lot of those nutrients that these fish consumed while they were out at sea around these river streams and these places where these fish are being eaten. And those are nutrients that are feeding and giving energy to the flora and fauna of that region. And it goes vice versa too. Another example here, I have eelgrass. And eelgrass, well, they grow on a layer of sunken topsoil. Topsoil that like formed from the debris of organic material from when the land the eelgrass is on was above water. So these are land nutrients that are now being used by the eelgrass, then that host many creatures, fish and crabs and all other sorts of good stuff. And same goes for like when land creatures are preyed on by aquatic creatures, right? So if a bird lands on water and it's scooped up by a bigger fish, and that's that fish is now bringing in all of those like nutrients and all those nutrients from that bird that lived in land, and down to the water where it leaves the rest of the bird to through poo as well, or just is eaten by other creatures. So that's a great example of the land-sea nutrient exchange, I believe. So I call it like the living conveyor belt, hence the title of the presentation, because it's like an exchange, a constant flow of nutrients from land to sea and from sea to land. Right, and I also wanted to showcase some of the fish that really play a key role in this nutrient exchange, right? So alewives are a big one. These are anadromous fish, so like salmon, they ascending rivers from the sea for breeding, right? So they live most of their adult lives at sea, and then to breed they go upriver or upstream. Whilst North American eel are catadromous, and they live their adult lives in rivers or other bodies of fresh or brackish waters, and then they breed. They go into sea to breed, um, and then their larvae return or the hatchlings return. Whilst amphidermis fish like the round goby, which is an invasive species, it's not native to Connecticut and the New England region, but it's already found here. These fish they can migrate from fresh to salt water at any stage of their life, besides like their breeding stage. So they can go from salt water to fresh water to hunt or to live or to hide, and they don't really do it because of their breeding patterns, but they do go to and from fresh to salt water. So like from the sea to rivers and other bodies of other brackish water bodies. And these guys play a really big role in that the dispersal and movement of nutrients, because they're the I guess the fish that travel the farthest, I would say, and probably consume the most distant things that might benefit flora and fauna of a specific location. Right. So the ecological impacts of aquatic migration. So first thing is like fish can move nutrients, but they can also move around pollutants. And they don't see the creatures oftentimes can't tell apart what's good for them versus what's not. Us included, right? It's unfortunate that like industry and agriculture tend to build around the same areas where fish tend to thrive, like these flatter coastal regions or flatter regions near rivers are oftentimes the perfect location for ports and heavy industry because of the easy access to water and transportation. Um, yeah. However, this also means that like a lot of fish and aquatic ecosystems are impacted by pollutants like spills, unnecessary metals that find their way into water, often because of rain and or flooding, bringing those into the water, and the fish will interact with them, either taking them in through their gills or eating them, eating the pollutants. Right. And there are laws that and regulations that are set in place to try and prevent these things. But again, because a lot of fish just like travel very long distances, you can have regulations and laws in certain places, but then not in others, right? So it's difficult to, especially with these wild fish, to get a good idea of what they consume, except for if we know their like migratory patterns, we have an idea of where they've been, right? So like if we know there's a lot of petroleum pollution in the Gulf, and we know there's a fish that like lives between, let's say, like the Long Island Sound and the Gulf of Mexico, and it just has that pattern, it's very likely that at some point it interacted with certain pollutants that are more common in that region, maybe oil, petroleum products, or something like that, and it's probably intoxicated. It has these things that are not good for us in it, are not good for other creatures as well. Right. Not to say that like mitigation and like all these other efforts are not important, but it's just the fact that these fish are wild and they move around very long distances just means that like there's very large likelihoods of them interacting with these like polluting chemicals. All right, and here is bioaccumulation, biomagnification, right? So they sound very similar, but however, bioaccumulation is the accumulation of substances, whether it's toxins or nutrients or whatnot, over time, as fish grow and consume other things or other fish, versus biomagnification is more the process by which larger or apex predator fish or animals absorb all the toxins and nutrients of all the creatures they consume, because they consume a large group of creatures, or the creatures they consume already themselves consume a lot of other smaller creatures, then there's an accumulation of those toxins as displayed in this little triangle, and the upward mobility of these like little dots, red dots, that stand in for like pollutants. So here is another image displaying how like bioaccumulation might work. In this case, it's mercury, which is a heavy metal, and how it is consumed. It gets into the sea and then it's consumed in small quantities by smaller fish and smaller crustaceans. But as the larger fish eat the smaller fish, it accumulates within them, and the levels of those like toxins, in this case mercury, just make the fish a lot more toxic for humans to consume. Smaller fish may interact with these toxins as well, but because they're smaller and that their body size kind of limits their consumption, they're less likely to have as many pollutants. And here I have an image of a warning sign you might find in a polluted area or polluted body of water in the state of Connecticut, just advising people not to eat the fish, right? So you could fish it, put it back in, because maybe it was a former industrial site, or there was like an oil spill or something, and you'll have different departments of the state place these to warn people of consuming toxins. So just another display of how this can impact us, and why we should try and be careful with what we buy and consume. Right, and then the importance of telling apart or catch is more about the physiology of fish. So if you're going to fish, but you don't have necessarily the most information on what the fish you're fishing consume, you could always just kind of tell by their body types that how they like what types of fish they consume and how they live, right? So I have a picture here of a bluegill and a North American pike, both freshwater fish that are found in many rivers and streams or rivers in Connecticut. And despite the fact that they both inhabit freshwater river ecosystems, they have very different body types, because they consume different types of insects and other creatures, right? So the pike is more of an aggressive carnivorous fish, a predator, a higher predator that's higher up in its food chain and its pyramid, and it has the features of like a very predatory fish: large jaw, has a sleek body for faster movement, and it's big, as a big fish, versus the bluegill, which is much smaller, rounder, has a smaller mouth, less of a like its body's less sleek. It's less likely to swim very fast in water, but instead it like probably focuses on other things like catching bugs and things of that nature. And it's also a much smaller fish. That it lets you know like what its consumption patterns are, and how likely you are to get something like heavy metal poisoning from consuming one of these, right? So less likely with bluegill, probably more likely with a pike. Even if you don't necessarily want to eat a bluegill, but it's just an example of how that could help us, and just some other examples here, some other images and diagrams with some information, which you can look into if you're interested. And finally, just like seafood mindfulness, right? So the types of toxins possibly found in wild-caught fish tend to be different from those in farm fish, right? So farm fish, wild-caught fish have different issues they face, right? Cook fish well to reduce the fat where toxins might be stored. So this is important. So like when you're just eating any creature, but at least especially wild-caught creatures or creatures that you hunt, just make sure you cook them well and get rid of all the fats. That's where most of the stuff you don't want to consume is stored in the bodies of those creatures. And be aware that different lifestyles and different ways in which the fish grew or were raised are going to impact what the quality of the food and what it could or couldn't do to you, right? Frequently consumed fish such as marlins/swordfish and bluefin tuna can contain larger amounts of heavy metals due to their position in their respective food chains, right? So marlins and bluefin tuna are a very popular fish here in the U.S. and they are very high up in their food chain. So these are fish that are very likely to maybe contain higher levels of like heavy metals or petrochemicals versus maybe sardines, a much smaller fish, which consumes is less aggressively carnivorous and like has a smaller probably has a likely has a smaller amount of like mercury or heavy metals and petrochemicals in each sardine. So just something worth thinking about when we go and purchase fish at stores. And fish that gather in regions near industrializing countries tend to contain higher amounts of heavy metals and toxins. And fish from regions with large offshore petroleum industries also tend to contain higher amounts of petrochemicals and toxins. So just being aware of where fish come from or live in areas where they live can allow us to be just be aware of the possibilities of certain types of contamination or pollution or whatnot. And yeah, and this is not really to scare anybody. It's just like it's just a look into how these fascinating creatures and their lives, just how they impact not just themselves and their surroundings, but us as well, and just how their migration, like their movement patterns, just play a huge role in just like moving nutrients and moving less nutritious things and toxins and whatnot, and that's what makes them a conveyor belt. So they're constantly moving all these important things from the sea to land, and yeah, and that's the end of my presentation. Thank you very much, and have a nice day.